Okay, I'm live here with 52 weeks of AWS, and I'm continuing the journey of AWS Solutions Architect. Last week, we covered databases, and this week, I'm going to cover networking. So let's get right into it. I'm going to share my screen and start off with a networking demo here. So let's go ahead and get into this. Really, we're going to cover some of the architectural concepts inside of AWS. And by the end, you should know about a VPC, cloud networking, all that kind of stuff, subnets, internet gateways, route tables, all kinds of good things. All right, architectural needs. Networking is part of an AWS architecture or a larger architecture. That's really one of the key concepts when you're dealing with the networking environment. And it's important to realize that, right? Like you're building out something that can handle the traffic going back and forth between different things, from virtual machines to storage, et cetera. In the cloud in particular, it's really an important component to what you're building. So let's go ahead and create a AWS networking environment here. In particular, with AWS, you can see that a VPC is really the center of the universe when you're dealing with networking. It's a way to provision a logically isolated section of the AWS cloud so you can launch these resources in a virtual network that you define. And that's really a key concept about cloud computing in general, is that everything is virtualized. So what do? You can bring your own IP addresses, subnets, routing rules, network configuration, security rules. So every single thing is controllable by you, and it's completely virtual. A VPC deployment means that you can deploy a VPC in any region as well. So this could be, for example, in South America or Europe or East Coast or West Coast or whatever you want to deploy. And then in particular, there are these availability zones, which are physically distinct regions that allow you to architect things that are highly available. So in particular, a CIDR is something to be aware of. A CIDR is something that comes up all the time when you're creating a security group. It means essentially who can access it from an IP routing perspective. So if it's 0.0.0/0, that means anybody in the world can access your resource. If it is, for example, 10.22.0.0/16, first of all, that's a private routing, so it's only available to be routed inside of your own network, but that would have a different list of addresses. So, in this 16 CIDR, I believe it says there's 65,536. So this is one of the key components to building things from scratch. Subnets, this would be dividing your VPC. So a subnet is a segment or partition of a VPC where you can allocate a group of resources. They're not isolation boundaries. They're a subset of VPC CIDR block. The CIDR blocks can't overlap each other, and they also reside within just one of the AZs or availability zones. You can add one or more subnets in each of the availability zones, and AWS reserves 5 IP addresses in each subnet. So there's 5 that you can't use. And VPC design best practices basically create a subnet per AZ and divide your VPC range across all of the availability zones, and then don't allocate network addresses all at once. So instead, you want to reserve some space in case you need to build things up in the future. You also want to size your VPC CIDR and subnets to support significant growth, and make sure that you ensure the CIDR blocks don't overlap with your organization's other private network ranges, right? Because again, everything's private in a VPC, and you're doing, private host to host or subnet to subnet communication. That's a very important consideration, is how to design it so it can build in the future. A single VPC deployment, there are limited use cases where deploying one VPC might be appropriate. Small single application managed by a small team, high performance computing or HPC, identity management. But most cases, you should have 2 primary patterns for organize your infrastructure: a multi-VPC and then also multi-account. So with multiple VPCs, you're best suited for a single team or a single org. And these would be things like managed services, Limited teams make it easier to maintain standards and manage access. And then exceptions would be government or compliance might require a greater workload, isolation. So just a few things to think about. In general, you're probably going to be using multiple VPCs in a larger organization. Multiple accounts as well is related, right? Because you could have a data science team, you could have a software engineering team, product management, QA, etc. They all may have different accounts, and you may not want them to be able to access data and resources between different accounts from a compliance perspective, and also maybe a billing perspective or cost perspective. VPC service limit, you can have 5 VPCs per region per account. So that's definitely something to be aware of. That could cause an issue if you aren't architecting that from the beginning. So in general, VPC is your main tool really to isolate parts of the AWS cloud, and it is something that is important to be an expert in. Okay, let's talk about connecting AWS into the internet. That's the next thing here. So if you want to create a public subnet, this allows you to communicate resources in your VPC in the internet. They're horizontally scaled, redundant, highly available. They're a target for route tables, for example, and they allow you to direct traffic between VPC resources. So route tables are required between VPC resources, and each VPC has a main default route. And so the subnets have to be associated with a route table, but you can create custom route tables. So that's an important thing to be aware of. You can also remap an IP address from one instance to another. And this is a really cool feature of AWS is this elastic IP. So you can create an elastic IP. It's got a static address associated with it. You may go into route 53, map a domain name to it. And then if the underlying machine, you want to just get rid of it or upgrade it or change it or whatever, you just swap that IP address onto the new machine. And that's a really cool feature of the AWS platform. You can also connect private subnets to the internet as well. And so you can enable instances in a private subnet to initiate outbound traffic to the internet or other resources. And you also can prevent private instances from receiving inbound connection requests from the internet. So what are some use cases for a subnet? It could be data store instances, batch processing instances, backend instances, web application instances. These are all good examples. So in the case of a data store, that would be a private subnet, batch processing, private subnet, backend instances, private subnet. Web application could be public or private. So I think one of the things to consider here is that, in many cases, you just don't want people to access your private resources in AWS. It's just security a whole, right? If you have something that's doing batch processing, why would anyone in the public ever need to access that? And that's really where these private subnets come in handy. A bastion host is a really cool concept. And really the concept of a bastion host is that this one server is exposed to the outside world. And then from there, you hop in and you make connections to other places inside of AWS. So really it's like a hop off point. So in order to create VPCs, I guess I could go through that really quick, just conceptually. But the idea with a VPC is that, again, it's an abstraction. Okay, what about securing your AWS accounts? Stateful firewalls are a great way to do it. Inbound, outbound. They act at the level of the instance or network. So you'll set these up if you're going to, launch spot instances, or you're going to create some resource, database. You would want to create some kind of security group hole so that you know what everything is talking to. The default security groups basically don't let anything come in, but they do let you go out. You may want to change that depending on what it is that you're doing in the future. There's also custom security groups. So these custom security groups can do things like, for example, open up a particular port to the outside world, like port 80. You can change security groups as well. So you can have, basically one security group talk to another security group, talk to another security group. And that's a great way to control things logically as well, because you're doing group-to-group communication. Network ACLs are a great place to look into what you're building. These allow you to, control the network level permissions. So they're slightly different than security groups. A custom network ACL, this would be things like allow SSH but deny all traffic, or allow this custom TCP port but deny all traffic from the rest of the internet. So securing your infrastructure with multiple layers of defense is a pretty good practice for security in general. So instead of having like a castle where you just breach the wall and then that's it, somebody's in your castle and you can't do anything else. You want to have these layered, parts of security. So there's so many different aspects of security that someone has to get through in order to get inside of your ecosystem. So in general, to create a public subnet, you must attach an internet gateway to VPC, point the instance subnet route table to the internet, make sure your instance has either a public IP or elastic, and then make sure the security group and network ACLs allow traffic to flow through. Okay, let's really, I guess in a nutshell, just talk about VPCs a little bit here. We can maybe skip this, but I guess in general, just to wrap things up, the VPC is a centralized component of cloud computing, and it's important to know how to use it with subnets, internet gateway, route tables, security groups. I guess I can just really briefly just show a little bit about these VPCs here. Let's just do a small demo. And the main takeaway that I would say is that it's important to know how to create them, right? So you can go to VPC, just find it inside of your console. There we go. You can go to VPC. If you want to create a new one, fairly straightforward to create a new one. You can just say launch VPC wizard. You can go through here and it'll walk you through all of the steps to do it. If you want to go through and create a security group, you can also create security groups by going to the EC2 console here and scrolling down and going to security groups, right? This is a great place to do things. And if you create a security group, a few things to be aware of, if you wanted to say, my database or whatever it is I'm creating a security group for, this is where you would go through and you would say, add some rules. So I don't know what it would be. Let's just say it's port 789 or whatever. And then I would say what can talk to it. And you could either choose maybe some security group, like you can see I can do security group to security group, or I could choose, I want everybody in the whole world to access this port 789. So that's really the concept, is create the security group, figure out what the port is, and it could be a range, right? Or it could be just one port, and then what's the source, what's the CIDR that I want to talk to. Always a good idea, someplace, whatever you want to put a little bit of information inside of there, so later if you look at it, you can figure things out. But in general, I would say VPC, security group, and network ACLs are all great things to be aware of, so that you can build secure ecosystems inside of AWS. All right, so not a ton today because the VPC section was fairly small, and the networking section was pretty small. But next week I'm going to cover. Let's see here. I'm going to cover next week the connecting. Let's see what I did this week. I covered creating a network, and now I'm going to cover connecting a network next week. So I will see you again next week, 4 p.m. Eastern time, and talk to you soon.